For anyone who just logged in, my name is Brian Sprange. I am one of the application experts at Javelin Technologies. I'm based out of the Winnipeg office location in Manitoba, Canada. And so, yeah, we're here today to talk about Industry 4.0. And really talk about how it relates to a typical customer of ours. There's a number of themes that we'll cover that make the tools that you're using today even more powerful. 3D CAD design tools, they're widely used currently, but often only for sub-assemblies or specific areas rather than a complete design or a digital twin is what we're going to be referring to it as today. So with the improved functionality though from the last few releases, your design tools, they're much more capable than they used to be. So we're going to introduce a few of these tools, and ultimately we'll review kind of the specific tools. If you've got questions, we can review those with your design leaders and help apply them in your current scenario and for your design best practices. So manufacturing today uses some aspects of the design data, mostly the 3D shape information, but in Industry 4.0, we want to really leverage the full intelligent model, providing the accurate tolerancing information for CAM and inspection, and interactive assembly documentation, which often renders traditional drawings actually optional. In the past, tracking changes and project approvals, it was a bit complicated, required dedicated resources, but in Industry 4.0, the document management really helps people find the information they need and track the changes without adding that extra work to the designer or to the shop floor. So you heard me reference the digital twin. This is kind of a couple of just images representing that. But what do we mean by that? Really, the big meaning behind digital twin is having a digital twin that will hold everything about a product. So whether it's a project, a city, or even yourselves, being virtualized can be really powerful. An example is if you had a motor in a power plant, like in the bottom right image there, go down. Being able to leverage that virtual twin allows you to quickly know everything you need to know about it. So you know where it is in the plant, the manufacturer, the replacement procedure, maybe the cost of what it's going to cost to replace that, how long it's going to take to get it in, so your shipping time, what your backup procedures are, because everything's connected by that digital thread. So that's what we really want our customers to get to, is that level of intelligence and automation in their designs and making sure that they have all that information easily available for them. So we called it Industry 4.0 a couple times already. And what it's really referring to is the fourth industrial revolution. So to quickly recap some of the previous ones, the first one is really seen as when steam was used to help manufacturing. The second is when we switched from steam to electricity, and that gave added benefits of just having more automation. You can have sensors and stuff like that. The third industrial revolution is the introduction of robotics and also just the internet as well. And then the fourth is moving from just the internet to full mobility. So that bridge between the digital and physical environments, and introducing things like the Internet of Things and big data, cloud computing, all those buzzwords you guys have all heard about. So to dive a little bit further into Industry 4.0, really what it's all about is that digital twin and how everything is connected. So we want to make sure that data is readily available either in the cloud or through system integration, and that we can use augmented reality to allow our designs, our manufacturing, and we can use it in places we never even thought of before. And really what this all boils down to is how the Internet of Things means having products communicate back and forth to us for future design improvements and even in turn, better customer satisfaction. So we'll see how that all ties in together today. But with all of this digital twin and all this extra data we're getting, it all comes with exponential data growth. So the biggest thing is we need to make sure that we have systems in place to control and tame that data complexity. So that's how we'll see how SOLIDWORKS PDM today is going to help us keep everything organized. So to jump into the actual content, what we're faced with and what we're going to follow through today is a company, Abco, has contacted Javelin Design Services, which is our fictional company for today. And Abco is growing too fast to manage their in-house design of add-on equipment for their machines. So they've contacted suppliers with a request for proposal, or an RFP, to submit designs to supplement their filling machine. So we're going to bid on this, and so we'll see what that's going to look like. In this particular scenario, we're going to be filling soap bags and designing a conveyor system to quickly transport the bags for packaging. And this is going to allow faster throughput of the filling machine from Abco. So the conveyor is going to have to take filled bags off of the filling machine and arrange them into 4 bags per group, then take those 4 bags and put them in a box. So we'll need to get our team together and work out a concept to present to ABCO. But before we do that, we're going to break down the traditional silos between departments. So for example, the silo of data that you get between mechanical and electrical engineering, usually they don't communicate all that well. And we'll see how having great tools and systems in place is going to allow us to feed that digital twin so we can collaboratively get up to speed and get onto the path to achieving that Industry 4.0 environment. So the team we're going to use today is going to start off with Scott Lidgy, our project manager. He's going to be in charge of our kickoff and any approvals and making sure that all the tasks get delegated through the PDM system. Then we're going to have Angus Hudson, our designer. He's going to be responsible for all our modeling, our drawings, and detailing out our designs when we get to that stage. We have Delvin, our electrical engineer. He's going to work in parallel with mechanical, as I kind of mentioned, to get all the schematic and 3D routing all done on time and, again, collaboratively at the same time. We have for validating our design, we've got our simulation expert, Savesh. He's going to test our virtual parts and scenarios to make sure that our designs are sound and that they're going to last and be good enough. Then we're going to actually leverage our marketing team. Vicky from our marketing team, she's going to use SOLIDWORKS Visualize to get that intrinsic value out of our CAD data without having to recreate it and see how really easy it is to get that. Finally, we're going to use Colin Murphy. He's going to be our technical writer. He's going to make all of our assembly and our technical instructions. So the route that we're going to take is we're going to go through this roadmap, visualize in your head, how do you currently start at a project? When you get a quote from or a request for a purchase from a company, how are you kicking off your project? Are you using a copy template from somewhere else? Are you copying, pasting your folders? Where's the control that you're using to make sure you get the right setup right from the start? Along with that, maybe if you have PDM already, you probably already have a method already established where you can get going with the design. So we're going to look at how that's going to start. So we'll start out with our project kickoff here. And we can see when we go into the user interface of PDM, we can just right-click anywhere to start a project. So we're going to be logged in as Scott Lidgy, our project manager. And here's where we get our template where we can enter all of our project information from a fully interactive and customizable environment. And the best thing is that PDM only needs this information entered once. So we're going to enter it right at the beginning, right when we first get our information. We know it's all accurate. We're going to put it in, and that's going to eliminate the errors and the ambiguity. So we're going to see we get a full project template, our folder structure set up. But we also get more things than that. We have PDM automatically creating our project set checklist here. So we have all of our information already filled out, and we know we're off to the right start. Again, eliminating those errors. But where PDM really shines is not just for CAD data. We can have things like our RFP. We can save this directly into the vault and check it in so that it's available to anyone who needs it. The nice thing here is even if someone's not an engineer constantly working in PDM, as you can see, it's a really familiar interface, just like Windows Explorer. So it's easy to get up to speed with. It's not hard to use. And we get that check-in control on our original RFP document. So we have that available for collaboration, but it's not going to get accidentally changed or have different copies floating around. Along with our RFP, we're actually going to reuse some data from previous designs. So we're actually going to search inside of our database for our pick and place assembly. We think that's what it's called at least. So we're going to use that SQL database, and we can see we find our assembly. We've just found the assembly file. We haven't found all of the folder containing or anything like that, just the file. But right from there, we can click on that assembly file, preview what it looks like, and this preview is powered by eDrawings. So we can even move it around and take a quick measurement to make sure it's the right size. And from there, then, we can take this, just from that one assembly file, we can grab the whole tree of parts for this, make a copy of them, and we have full control of the referencing. We can change the name. If we want to add new serial numbers to all of these, we can do that so we have new part numbers. And we're going to take all of that, copy that into our new project, and then let's move into SOLIDWORKS and set up our assembly. So we have our customer file, or our customer assembly that ABCO sent to us that we're going to base this new conveyor assembly off of. So we need to create, we need to go into create an assembly and bring all this information in. But SOLIDWORKS PDM has actually already automatically created our top level assembly here. So we can see we didn't even have to go in and make a new assembly. We already have the project number associated with this. It's all linked together. Just a nice little add-on there. So we're going to open that up. That was the top level assembly, which was auto created. And we're going to bring in the customer supplied assembly from ABCO. We're just going to place it right on the origin and get that locked in place so we're ready to go with our design. So remember, this is still the project manager doing this. This isn't even our designer. We're just doing this ahead of time, saving our designer a bit of time. Again, we've got that existing design from an old project. We're going to bring that in. Nice little trick. We can filter top-level assemblies to get rid of all the view of all the other parts in there. And so we can bring in this previous assembly here. And using these pink dots, they're actually magnetic mates. We can just get it close. And then once we have it close, we can click it exactly where we want, and it's going to lock those pink dots together and get it oriented exactly how we want it. So making it really easy to bring these assemblies in, not even requiring us to know how to use mates or anything like that. So with that done, we're going to check in this top-level assembly we just created really quickly. We've got the customer model, we have our previous project model, and so we're going to use the PDM toolbar built right into SolidWorks here. So we'll check this in. We're going to leave a quick note just saying that this is kind of the starting point of our design here. And then we're going to move it through our workflow to get it ready to go for concept design. So this is where we can choose what designer we're going to use. Leave a quick comment saying what we're looking to get. So we want to do a concept design for this just so we can set it out for a quote. But the biggest thing is we want to change out our frame design. If you noticed, it was kind of a sheet metal and some custom weldments here, some custom tubes. We want to just simple design, and we also want it to match that ABCO frame. So we're going to recreate this frame. So we've sent this off to Angus, and we're ready to go. So right there, Scott Lidgy, our project manager, he was able to connect to the system and manage the data that allows us to leverage anything we feed into it. And we eliminated the repetitive tasks. So we didn't have to create those folder structures, which ensures that the parties are all informed at the right time. We leverage the data that we had already created. And also with that, we're able to leverage those lessons that we've learned in the past. But most of all, we've saved time, money, and we're reducing those errors by making sure we're entering data only once and then just reusing it. So we've got our project kicked off. Now we're going to go into our concept design stage here. So becoming Angus, our designer, when he logs into PDM, he's going to get a notification here. And the nice thing with this notification is we have a direct link to the model. So that exact folder that Scott was just working in, we have a link to that. So we're not copying in files and emails, ending up with multiple versions or anything like that. So we're going to go right into that folder, open up our top level assembly. Now we're working in the same environment. We're not having to worry about having things at different states or anything like that. So what we're going to get started with doing is we're going to open up this subassembly that we have previously and just get rid of that frame. So we'll use breadcrumbs here to just click on that frame, open that subassembly up really quickly. And then we need to check it out so we can make these changes. So we'll check that out, click on the frame, and just get rid of it. So the biggest thing here is that PDM checkout makes sure that only the people that need to be working on this are going to be working on it, and they're the only ones that can actually make those changes. So we'll edit this assembly in context. What we want to do is we want to create a design that's based off of those other parts in the assembly, that customer model here. So we're going to create a new part and then bring this into the assembly so that we can get all of those references, that opening in the customer assembly there where this is going to mate up to. We want to make sure we stay the same size as that. So this is going to make sure that if the customer model changes, we'll be able to easily represent that. So we can see we get that rectangle is a reference from the customer part. So we'll be able to carry that along if anything changes. And if we jump forward in the frame design here, you'll see we're just creating a 3D sketch with lines, which is the path that this is going to go along. So we're going to add some equally spaced supports here. What we're going to do is reference that overall height dimension and add an equation so that no matter how high this is going to be, those crossbars are going to be always spaced out a third of the way along, keeping it exactly how we want it to be. So with our sketch completed, now all we need to do is choose which profile we want to use. So we can choose that over in the side in our weldments commands, and then send that along our frames sketch here. So as we step forward again, we have all of our paths selected. And what we can do here now is, taking advantage of one of the new features in 2018, is use tab and slot design. So we don't have to dimension out where these tubes are going to go. All we have to do is say what tubes these are when we go to the detailing stage of this, and then they're going to be self-fixturing. So we can just put these tubes in place on the top of the part and we don't have to worry about measuring that out. We're going to ensure that they're consistently in the same spot because it's going to be a tab and a slot going in and locking this in position. So we can see that as we hide that piece, that we get those slots cut in the top tube. So it's just going to fit in perfectly. So with our frame design completed now, we can just save it and check it in. And the big thing here is when we check it in, we're going to leave a comment so that we have that history on what this is. This is the initial design, and this is how we're going to basically base our quote off of this design here. So we'll check that in, it changes the state of that, and then we can have that notify Scott that we have our design completed. So we just saw Angus. He's well informed. He was able to get that notification right when he logged into the system. He had that direct hyperlink right back to that folder, so he doesn't have to go hunting for it, and he's going to be working in the right spot. He can get right to work. He's able to leverage SolidWorks and all the industry-leading tools to get the project rolling faster. We saw he got to use tab and slot. We did a quick weldment creation and all of those in-context references. So this is where a lot of companies, I don't know of many companies that work exclusively in design and engineering. So we basically finished off our design, but the design and engineering teams, they create a ton of value. So how often are other teams asking for some of this value, whether it's screenshots or bill of materials or drawings for the shop floor? A lot of other teams and departments inside of a company need this value. So we want to make sure that we can spread the value around with the SolidWorks suite. It's going to allow others to use their CAD data directly. It's going to reduce the burden on engineers and designers. So we're going to take a look right now at how we can actually share that data right at the concept stage. So we want to add a little bit of a pop to our proposal to ABCO, but we need it really quickly. So Vicky in marketing, she's going to use SolidWorks Visualize to work in parallel with Angus, our CAD modeler, and create those renders for us. The nice thing is if there's any design changes, it's not a problem because Visualize has a direct link back to our CAD model, so it can update on request without impacting the work that's already been done. So our full scene setup, it'll just update as we need. So in this case, with the assembly and Visualize, we're going to add a scene. So that's the background information here. We're going to add a warehouse scene. So all we need to do is just drag and drop that from the side, and we're going to create that instant emotional impact when you see your actual part in that warehouse environment. So it just instant connection to it, right? Similarly, we're going to bring in a new appearance for our frame. We didn't apply a material to it, so we want to apply that steel appearance. The nice thing here, we have our SolidWorks appearance that if you've used PhotoView 360, those will be nice and familiar for you. The other option we have is we can even go to the cloud and get plenty of online free to use appearances that we can download and apply. And again, this is just a simple drag and drop from the tree over on the side directly onto the part that we want to put it onto. And you can see as it updates there, we get a really great looking rendering here. So with that kind of set up how we want, we can go directly to our output here. And what we're going to do a little differently is we're not just going to render it right now. We're actually going to send it to a queue. And where that really comes into play is that we don't have to wait for this to render. We can just send that to our queue, and then when we go on lunch or maybe at the end of the day, we can let our queue work its way through and render those out so we don't have to leave our computer and do something else, maybe go for coffee for a bit. But we can keep working directly on our models and just set up a nice long queue. So we see that here. It's completed. We finished our rendering. And so what we're going to do is actually add some extra value to this. Make sure that this rendering is available to anyone. We can see we can preview it right inside of PDM. But what we want to do is actually copy this. And then we're going to go back to that top level assembly, and we're actually going to check that out so we can make a quick change to it. And the change that we're going to make is we're going to paste that Visualize rendering directly onto that assembly file. So it sounds kind of funny because we're pasting an image onto a file, but by doing it this way, that rendering is going to follow this file around no matter where it goes. So we're always going to have easy access to that rendering. And again, it's going to easily connect our digital thread together, which maintains all of our information in one place. Easy to find. So in the digitally connected environment, we're working in, Vicky is able to leverage that design data. So she's able to just pull that CAD model right out, which in this case, as we mentioned, it's our digital twin. Even though it's still in design, and she was able to start creating some really professional looking product images to help us with this project. So really the biggest thing here is gone are the days where you have to wait for the product to actually be manufactured and then have expensive photography come in and take pictures of your part. We can get those basically pictures ahead of time. So we've got our concept design finished now. We even have that added pop of the render. So let's send this out for approval after a design review. So Scott, Angus, and Vicky, they're going to hold a quick design review. Everything looks good. But actually, Scott realizes after the design review, or maybe in it, that we want to send this out and get some more information. So he's logged into the Vault. Again, he gets that notification with those links. Super important here because we're not copying files. When Vicky finishes, she's not having to email out that rendering to all the people on the team. She just attaches it. He can see that rendering really easily. But this is where he's going to decide this assembly. We want to make sure that everything's good. So we're going to send it for a quick validation, even though we're just in the concept stage. So we can change the state. Instead of going to release for a quote, we can just go to further analysis here. So we're going to send that through this validation workflow, and it's going to go to Saivesh, so we can choose who it's going to go to. Again, leave comments so that Saivesh knows what he needs to work on to ensure that there's that clarity included with this. So now we're going to jump out and see what Saivesh is going to be doing. So we're going to, for our validation, we want to validate the motion of that arm. So we're going to run it through a quick motion study. And then from that, we're actually going to do our stress analysis study from the results and based off the results on that motion study. So we're going to use a pathmate to define our motion. We have that arc right here. And using that arc, we'll go in, set that as the motion that we want this to go along. And then we actually just let SOLIDWORKS calculate what motion it needs to use for that arm to mate that. We can see we have a preview of what that motion is going to look like here. We can choose how long it's going to take to do that motion so we get accurate results. And then we confirm that and calculate, we get this great animation that shows exactly what that motion is going to look like. We don't just get a great animation though, we get some amazing results from here. So what we can do is we can extract the force information. So our angular velocity, we can get all of that. The nice thing with our angular velocity, we can take this information right here and just send this over to our controls team, and now we have our motor programming done. And remember, we're still in the concepting stage. We're not even sure what we're going to be doing yet, but we already have exactly what we need for our motor programming. We can also extract data, which is going to be the force on the frame. So based on this movement, what is the frame going to be seeing for forces? We can get that information in both X and Y directions, so we know exactly what we need for strength in our frame. And then finally, we can see what the power and the torque requirements are going to be for these motors. And in this case, some of the motors that we have spec'd out in this design, because this was an old design, maybe it was picking up something heavier, they're way over spec'd. So we're spending extra money on super powerful motors that we don't need. So we're going to find that out really early, and then that's going to let us save money down the road by re-speccing out different motors. So to do that new spec, we're going to use 3D Interconnect. So it was introduced in 2017, and then in 2018, we now have multi-CAD, or we have support for STEP, IGES, and SAT files. So it's going to give us a really powerful and easy way to deal with native CAD geometry or translation geometry, and we'll see that here as we jump back into our assembly. So we've got this motor on the top. We're just going to delete it, and we're going to bring in a new one. So we can just import a step file here, and you'll see we don't have to go through the step of actually going into the part, saving it as a SOLIDWORKS part. We can just bring that right into the assembly and start using it. So we'll mate this in place, and with that in place, we notice we've got a concentric mate on one of the bolt holes, but when we go to add this concentric mate on the side here, they don't line up perfectly because maybe this motor is modeled in inches and we model in metric. The thing here, though, is in 2018, we can actually have a misaligned concentric mate. You can see this is a great use for it here because even though this doesn't line up perfectly, and normally SOLIDWORKS wouldn't let us do this, we can have that misaligned concentric mate. We know this is still going to bolt up nicely because those bolt holes line up. We just have a bit of slop so that we can adjust the placement of this as we need for setting this up. So it's a great example where those misaligned concentric mates is really useful. And those are all controllable at the system level as well if you don't want them. So with that motion study done, we're going to start our static study on the frame here. So we'll start that up. We're going to add our materials, add our forces, add our fixtures. In this case, our fixtures are going to be the bottom of the feet and where it's going to bolt up to the frame. The nice thing is we can see these little balloons. This is SOLIDWORKS recognizing that it's a weldment. So it's going to assume things like a constant wall thickness just to make the simulation run a lot faster. So apply the fixtures, and then the biggest thing is we're going to actually apply the force directly from the library. So we've saved the forces from our motion study, and we're just going to drag and drop that out into our part and then choose where that's going to be placed. So it makes it really easy. We know we're using the right forces. Drop it on that face, choose which direction it's being applied in, and we're done. So really easy to get that simulation study started. We'll give it a quick run. And now we're going to just check the displacement here. So the maximum displacement we're getting is 0.08 millimeters. So we're going to be more than fine in terms of how much this frame is moving as we're going through the motion of moving these soap pigs. And the next thing we want to do is make sure we have a good factor of safety on this so that our frame is going to be strong enough. We can see our factor of safety is 59. So we know that sending this quote out, we're going to have confidence in approving this concept because it's not going to be undersized. And when we go to manufacture this part, we're not going to have warranty issues. We'll be fine. We could maybe even lighten up the frame a bit if we wanted to. So testing the design ideas as we go along with simulation allows us to have great insight and confidence in our design decisions because it's part of the same ecosystem. There's no reason why you shouldn't be validating your designs. We're in a 3D world, but not everyone chooses SOLIDWORKS as happens in the real world. But it's great to know that SOLIDWORKS, we can still work with those files, that motor file that's not in SOLIDWORKS, whether it's a step or something else. We can still leverage all aspects of that data as you saw when we replaced that motor there. So it's really easy to just bring that in. All right, so we have our analysis done and we're going to submit that out to Scott. And Scott's going to review the results and approve the concept. Finally, he's going to send out the quote to ABCO and see if they like our quote. At this stage, all the data for that quote is all in one place. So it means it's really easy to get all that information and have it available as it's required. All right, so we're going to wait to hear back from ABCO in this case and see if they approve our quote. And the end result is that, not surprisingly, because we had those extra value adds, we had that rendering attached in, we're all organized, so we had our quote submitted on time. It was really easy. It means that our quote was approved. So that is great news for Javelin Design Services. So we're going to see how we can take it a couple steps further here. So we have our quote approved. Now we're going to go into our detailed design. And they asked for some components to be optimized prior to completing the review, so we'll see that. But first off, we're going to update our drawing package so we can get started with manufacturing this. In this case, we have our old assembly drawing from when we previously used this design, but we're just going to reuse this and just relink things. So we can see we have these flag notes here. We'll just reattach them to our frame. Not an issue at all. We can drag and drop to reattach those balloons to our new geometry. And of course, we can use the magnetic lines inside of the drawings to clean up our balloon placement, as you can see. So it means that our balloons are really nice and tidy. What we're going to do now is we're going to actually open our frame directly from this drawing just to save some time. So we just click on our frame and click open. And then we're going to start our new frame drawing here. Because this is a new component, we don't have anything existing, but we'll get started right away. So we'll drag out a couple views from the side, and we have those guides to make sure they get placed exactly where we want. But then the next thing we're going to do is recreate that cut list. We're going to, in one click, generate our weldment cut list so we have full information in terms of the length of each piece and also the overall length. We can resize this, and one of the really exciting features in 2018 is we actually have a button to turn all of the text inside of this table to all uppercase. So most companies require that in a drawing, any tables are going to be all uppercase, so we can really easily do that. You don't have to break links or anything like that. It's a feature I think Windows should have. So we have our drawing getting going here. We've got some balloons. Now we just need to add some dimensions. So for this, we're going to use model items to use the dimensions that we use to actually design this part. But in this case, there were some dimensions we're missing. So if we want to add some more, we can add things like a baseline dimension to just easily choose where we want to locate these members, place those there, and you can see it automatically gets all that information really easily. If we have to show a specific member, so like this one that has angled cuts on the ends, if we want to show more detail, we can go in and show just a specific member, even though this weldment frame design is all contained inside of one file. We can just choose exactly what we want to show. So you can see that here. And then we've completed our drawing package really easily. So we're able to just reuse the existing package and just go from there. So Industry 4.0, it may be more difficult to attain for some, which means that from time to time, we may need to revert to some older methods like our 2D drawings, but to support those other companies, or maybe if our company still wants the drawings on the shop floor. So it really is nice knowing that SOLIDWORKS, we still have all those tools to prepare this, and it's really easy. We can just reconnect things, use existing drawings, not an issue at all. So keeping in our detailed design, We're going to work in tandem, and I mentioned this earlier, we're going to have our mechanical and our electrical teams work in tandem here. So let's see what we can do in SOLIDWORKS Electrical. Remember, we had those motors switched out by CFS, so we need to update our electrical design to reflect that. So the electrical project, it's organizing all of our pneumatic, our hydraulic, and our electrical designs along with our 3D mechanical designs. And so to replace those motors, we're just going to go online and search for our new low inertia portal or low inertia motor using our online portal. Once we find the one we want, we can download that to our local library, and that download contains the component information and our symbols. So it's going to save us a lot of time in setting this up. We don't have to redraw it. We're going to select the motor we want to replace and just choose that one from our library that we just downloaded. And SOLIDWORKS Electrical is going to automatically identify those new connections, and it's going to be updated everywhere. We can see it just switches that out. Really easy, not a burden at all to do those design changes. So if you have sections of your design like this power supply that we're going to be reused on either this project or other projects, we can easily create a library feature or a macro that is going to allow us to just drag and drop that out, just like we're familiar with in SOLIDWORKS. So it really saves a lot of time being able to do that. And all that component and part information is saved in here as well. With those new components added, we do have to do a quick update on our wire numbering, but we can do that automatically. And the other thing is that a lot of our schematic designs, I mean, it's not a simple schematic a lot of the time. So they're going to span multiple pages. But when we're making these off-page connections, it's really easy because SOLIDWORKS is going to maintain everything and make sure that we're not connecting a signal to a power or anything silly like that. It's going to make sure that it is all intelligently done and easy to set up. So the schematic application also ties in with SOLIDWORKS. And so as we move into the SOLIDWORKS interface, the project's available for the mechanical engineers, and they can just drag and drop these new components that we've added in here. And you can see they snap in place, and it's really easy to bring those in. The wires can also be automatically routed, and they're going to inherit bend radius and colors and core diameters from our project settings. So again, it's going to keep phase and control wires separated using special tools. We can get all of our cable lengths, and our duct fill ratios are going to be calculated to make sure we're meeting code. So it makes everything really simple. Finally, with our project done, we need to create some reports. So inside the schematic application, we have some great report generation features. Like we can do this PDF here, where all of our off-page references are going to be maintained. We can click on things to find where to go, where things are. These can be really useful for troubleshooting a system or even just going paperless, as the documents can be opened on a handheld device. So when you're on your shop floor, we can have all of our schematics just online, really easy to access, again, stored in that PDM vault. We just saw a perfect example of breaking down that traditional data silo. We don't have electrical working completely separate of mechanical. They're working together on the same data set, everything's saved in the same place. So who knew that mechanical and electrical can get together, get it along so well, and work tightly together. So really the biggest thing is they're helping each other get their jobs done, and it's going to be faster, it's going to be more detailed, and we'll have fewer errors going forward, which is going to in turn mean less rework. So along with our electrical team doing new or updating their design, we have Colin in our technical documentation team. He's going to work alongside our mechanical team and our electrical team and Vicky in marketing to make our technical documentation. So we're going to see what that's going to look like here. In Composer, it allows us to easily create that technical documentation. Here we have our filling machine, and we need to make some overall layouts to start with. So we're going to go to this top view, throw in a couple dimensions, and we'll save that view. And we'll see as we're saving views, they populate themselves over on the left there. They fill up that tree. So moving back into our default view, we want to get a detailed view for this motor. So we're just going to select that and go up into our workshops. And then from here, we can create a technical view of this, and it's going to be fully customizable over what it looks like. So we can adjust it once we bring it in. Once we get it exactly how we want it for size and everything like that and position, we can save that view as well and go forward. So we have that view captured, and now we want a view of just our pump. So we're going to zoom in, isolate that, and get even more detail. Once we have that exactly how we want it, again, we'll save that, and you can see we're filling up our list over on the left there. We can use some translation tools to move these parts around inside of Composer, and so this is going to make our assembly instructions really easy to create. We can even move multiple parts at the same time and have them spread out automatically. If you've used exploded views in SOLIDWORKS, very similar technique here. So we have our exploded view started. We want to add some more information. So these lines here are for the explosion lines, and we also want to have this arrow showing exactly how it's going to be taken apart. All of these features, we have a ton of properties we can change around on these, and it makes it really easy to clearly detail our assembly instructions. You can see here exactly what we need to do. We need to loosen that screw off to be able to take this apart or assemble it. Once we have that saved, the biggest thing here is animations. They can really help tell the story. So as we go through, what we're going to do is create a timeline and then just drag and drop views onto that timeline to let Composer automatically make our animations. It's going to interpolate between our views and just automatically create this. So we'll see that right here as we drag them on. And as we hit play, now we have our view animating, and it makes those animations really easy to create. We just let it do the work for us. So we can, the biggest thing here though is, remember, we're working at right when we got this file. So if we have an update though, we can update our file directly from SOLIDWORKS or from Composer. If we have a new Composer file, we can do that update, and all of our views, if you watch over on the left here, all of our views update at the same time. So we don't have to go through and recreate these. So a lot of these views, you're probably thinking we could make these with screenshots, but then the problem becomes if you make a change, now you have to go through and remake all of your screenshots, and you're never going to get them exactly the same. So this is where it's really nice. We can just have it automatically update and generate all that information easily. So now that we have our full assembly in here, we need to create a bill of materials. So we're going to just go in and get our view set up exactly how we want, choose our bill of materials, get our part, and get all of our information inside a Composer even, so that we have all of those links to the parts. We can easily see what we need when we're assembling this. The next thing we can do here that is really powerful is we can bring in other file types that let us show tools and even other instructional visuals. So like a drill and a level, we can show how this changing or rotating this foot is going to help us get this level. You can see here, these views are really powerful. They're showing us exactly what we need to do. And the biggest thing is they're not using any words. So we can see here, we have 8 holes we're going to have to drill. In this case, we use 1 word and a couple numbers, but in this visual, we just need to use safety glasses when we're drilling, so we make sure we're wearing that professional or personal protective equipment. So you can see, really easily creates those super powerful images to help us get to this next step, which is our assembly instructions. So we can get our overall views on our title page, and Composer is going to help us create these really high quality vector-based images. We can see, just taking a quick glance, I'm pretty sure everyone out there is going to have a really good idea of exactly how to assemble this. And there's so few words, we're going to make sure that everything's done properly. Beyond creating these just static images for assembly instructions, we can also create interactive web content. So here we can move and investigate models, and we can navigate using these thumbnails. We can even attach links, so that for this motor here, we can go directly to that installation manual. So we have all of our instructions exactly where we need them to be, and they're at our fingertips. We don't have to go hunting for things, making sure we have the right manual. We do it once, have it connected, and then we're good to go. So you can see some really powerful tools there. Colin, just like everyone else on the team, was able to leverage that same digital data to add his expertise of creating amazing technical documentation into this project. So he easily created that assembly, operational, and service procedures in both traditional and PDF interactive, in both traditional PDF and also online interactive formats, which really connects that digital thread even further all the way to customers and service teams and out onto the shop floor. So we're not just connecting the digital thread within our organization, we're going all the way out to our customers. It's fantastic here. So we have our detailed design completed now. We've done everything we need to do. What we want to do though is actually go and do a secondary analysis. So the last one was focused on, would it work? Is it going to be strong enough? Is the motion going to be accurate? But SOLIDWORKS 2018 lets us look at how to make it work best. So CFS in this case is going to look to optimize this connecting arm for weight and strength. So we're going to use a new study type inside of SOLIDWORKS 2018, which is a topology study. So we're going to open up this part, and we're going to see we're able to use the same forces from that motion study, again, reusing our data, making sure we're using the correct data as well. And then we also have goals and constraints here. So what we want to do in this case is our goal, if we take a look at this, we want to reduce our weight by 70%. That's what our goal is going to be. But in order to do that, we do need to make sure we reduce it in the right spot. So before we go through and just jump into this, we want to make sure we use some manufacturing controls here. So we're going to look at these, and we have preserved regions. So we're going to choose all those faces that the motors are going to bolt onto. So we make sure we have enough meat there for our motors to mount up to. We're not going to have issues with that. And then also we have a demold direction, and think of this as a machining direction. So it's called demolding, but if you think of it as machining and the direction the machine is going to come in from, it's going to make sure that we can still manufacture these parts using traditional methods. So with everything set up, now we're going to see what the results are. And so we got a plot of what's needed and what's not. We can smooth that mesh out for 3D printing if we wanted to, or if we're still a more traditional machine shop, we can use that result as a simulation display and overlay that on the part. And then from there, create a sketch that will allow us to use this topology study while still manufacturing traditional parts, but kind of a hybrid area, which is really cool. So you can see we get that sketch, which is going to be the areas we can cut away. So we'll do that now. We'll cut that out. And we get that optimized shape, but we're saving on material costs. It's going to lower the power requirements even further for our motors. We don't have to move as much weight around. And SOLIDWORKS makes it really easy to find that end result. So when we go back into the model, we can see that part's updated when we save it and check it back in. And again, we could 3D print this part if we wanted to, or if we still want to just do a traditional manufacturing method, it's still a great way to get to that really organic and new shape. So the topology studies, along with additive manufacturing, they're taking designs to places we never thought it was even possible. So we can get the best out of all worlds also, because we can get those beautiful designs that function as we need them, and we can still design them for traditional manufacturing. And one of the areas that this is really powerful is we can actually take these designs, or we can use this method to actually save on shipping costs even, because a lot of parts are being shipped. And so if you can reduce your weight by 70%, you're going to save a lot of money on shipping beyond having great looking parts. So we have our secondary analysis completed. We're going to send this back, and we want to get Angus to do some geometric dimensioning and tolerancing on these parts here. So we're going to we'll start out by choosing our datum faces here. We can just easily select those, and that sets up our primary and our secondary datums. And then we can choose which features are going to be tolerant to these. And these are going to be just automatically created based on our system and our project settings. We get graphical feedback for our faces, whether they're fully defined or whether they need more information. And we can even go in and manually add size and feature dimensions. We can choose, again, we're just graphically choosing faces is much easier than choosing an edge or anything like that. And once again, we have those dimensions coming out, and we're getting the tolerancing based on our project settings. So we don't even have to type it in every time. If we're using standardized tolerancing, it's really easy to get all that information. With our dimensions and our tolerances all added on, we can create our first view here. So we're going to do a side view, and we have the notes that can be stored in the library for reuse. Once we have that side view created, we can generate an ISO view. And where I was mentioning the notes storing in the library, if we go to our library, we can have our general tolerancing note stored there and just drag it out, drop it onto our part, and we don't have to type it every time. We're going to ensure that it's the same every time. And then we can save this view as well. We can turn annotations on and off if we want to. We can also do things like create these really powerful section views here using this transparent zonal section view. When we have that created, you can again choose which annotations are going to be shown, so we only show the ones we need. And the other thing we can do is capture configurations as well. So in this case, we're going to turn off the design found through topology studies. What we're going to do is we're actually going to recreate or show what the blank material is going to look like. So if we change our view to just hide everything, so we don't have any of those annotations, and then switch our configuration back to the original one, we can show that as well. So we can see what the original part is going to look like maybe for manufacturing here. With that confirmed, now we can change the order of these views. So we're going to put our isometric view with our general note first. And with that reordered, now we can publish this out to a 3D PDF. We can do e-drawings if we wanted. The other thing we can do is we can actually attach additional files. So in this case, we're going to attach our original RFP to this, so we can see exactly what this part is relating to. We can even attach a step AP242 version of that part file directly into our 3D PDF. When we jump in here, you can move the model around, you can investigate, click on the views, go through, and we can see even as we click on that dimension, it's going to highlight the face that that's relating to. So it makes it really easy to see our design intent with this part, because we can, it's not interpreting a drawing, we can see exactly what everything is relating to. The nice thing though, our MBD views, a lot of companies still aren't at the stage where they're ready to jump all the way into MBD, but we can create all of those views in MBD really easily and then just bring those into a traditional drawing. So it's still really easy to use a traditional drawing. We can set up the MBD views ahead of time and then bring those in. And we'll see as we step forward a little bit further in this process, we'll see where we can also use the extra power that we've added, or the extra intelligence we've added to our models from MBD. So we just saw that SOLIDWORKS, it's got the tools to support your Industry 4.0 initiatives. MBD is giving you the ability to tile that product manufacturing information directly into that digital model, so we're not relying on a 2D drawing. And it can eliminate the need for a 2D drawing, which will in turn eliminate the ambiguity that you get from those, and it sets up for even more productivity downstream in the manufacturing process, which we'll see now. So we have our secondary analysis done. We've completely finished our detailed design now. We're going to go through our final approval process here. So all of our drawings have been completed, and notification goes back to Scott, our project manager, to approve the changes that we've done. So he's going to go through, click on approved, and what's going to happen here is we can set this to require a password just to make sure, and he can comment on what the state change is going to be here. So we're approving it at Rev A, and then PDM is going to get to work. We're going to automatically stamp and revision all of our drawings. We're going to create some files, some DXFs and some PDFs. We'll see how those work. And this is all being controlled by a really powerful workflow. So we know that everything's being done right. So we've created some DXFs for laser cutting here, or maybe for stamping. And we even have an area where our released PDF drawings are going to be sent to. So our shop floor has access to this. So we can go to our released drawings folder and we can see now that drawing for that part that we just created the DXF for. We already have that created. We didn't have to go through and save this part as a PDF. Again, just saving time. So as we're approaching the finish line, a lot of things are happening here. Many people need to be notified that this design is completed. Many sign-offs are required and happening. We have lots of final information that needs to be distributed about, and PDM is going to handle all of this automatically. So having the system in place to do this automatically and ensure that no steps are missed is really critical to the success of both our products and our project. So we have our final design released, but before we disconnect here, we were able to create all of our documents. We kept everything organized and controlled, but now we need to manufacture this, right? This is where we really make our money, or this is where our customers make their money, is in their manufacturing. And then once we've manufactured, we need to do a quick inspection to make sure we manufactured what we thought we're wanting to. So as I mentioned, SOLIDWORKS MBD connects with other areas of SOLIDWORKS, such as the new SOLIDWORKS CAM in 2018, and also SOLIDWORKS Inspection. CAM runs inside of SOLIDWORKS and adds that parametric CAM functionality to our design toolkit. So we'll see how that's going to work here. We can even have it do tolerance-based machining, which is going to read our PMI from MBD and put that directly onto our part when we're manufacturing it. So we're going to set up our part for manufacture here. First thing we need to do is choose which mill we're going to machine this on. So we'll choose the mill. Once we have that selected, we can choose our tool crib to make sure we're using the right cutting tools, and then we can choose which post-processor we're going to use, and these come out of the box with a bunch of post-processors. Also, SOLIDWORKS CAM comes with a universal post generator, so you can create or modify a post-processor to be exactly what you want it to be. We can easily also set up the stock and position that. So we'll confirm our machine, then we're going to go into our stock manager, and this is where we can define our stock. There's multiple different ways to do this. We can do it with a sketch, as you can see here, the preview of our sketch. We can do it with an STL file or another part file, or even just the bounding box of the part. In this case, we're going to choose the sketch, which is offset from the bottom a little bit. We just set it, or type in a thickness for our stock. And then we just need to set up our coordinate system once we have our stock set up. So typical machining stuff here. Choose our origin point here for our coordinate system and confirm that. Once that's set up, we're going to click extract and extract all of our machinable features automatically from our part. So this is where MBD is playing into it to make sure that our machining strategies are going to match what we need to get from the part here. So we'll generate an operation plan and a tool path, or all of our tool paths, and then we'll do a quick simulation of how this part's going to be machined. So we can see we get a full simulation of the tool and the holder, what the faces or what material is being removed here. And this is all powered by CamWorks. So this is tried and true code. We're good to go here. We know that this is going to be great. We can generate our G code directly inside of SolidWorks, and then we can fire it out to a machine. And just like that, we're already cutting metal and we're manufacturing our parts and making our money. So you can see here, based on our post processor, we have everything already created. So now that our part's manufactured, we need to check it before we install it in our machine. There are inspection reports. I mean, a lot of companies are still doing this manually, either by writing it out by hand or in Excel, both of which are very time consuming. So we'll see how SolidWorks inspection can automate that inspection process and save time at the end of the manufacturing process, which is when we just want to sell parts, right? We don't want to be waiting for the quality team to finish up with their inspection. So up until now, inspections are great with drawings and PDFs, but now in 2018, we can extend this out to 3D parts as well, especially ones with MBD in them. So with our MBD part, we're going to start a new inspection project and extract any custom properties we want to populate our first article with. Inspection is going to automatically balloon all of our inspectionable dimensions or inspectable dimensions, and it's going to do that really quickly here. So we have that done. Now, each of these dimensions has characteristics and they're all fully editable. We can edit the things like what balloon type we're using, what this dimension type is, more importantly, what inspection method we're going to use to inspect this. So we can choose whether it's going to be CMM, whether it's going to be manual, whatever it's going to be. And then from here, once we have it all set up, our first article is ready to be created and exported. So we can choose to export that to Excel, or we can use online cloud inspection services like Quality Expert or NetInspect. In this case, we're just going to use Excel for this one. And we need to choose our template, and then we just hit go, and inspection takes care of everything else for us. So we can see we get our inspection report ready to go, ready to use, and we can fill that out. So we can export our model also to 3D PDF, so we can follow along in our inspection report with this 3D PDF of the model with all of our balloons in here. So it makes it really easy to find all of that, all of those dimensions. You can see exactly what they're relating to because it is a 3D PDF. In our inspection standalone, it's great for 2D and 3D parts. Dimensions can be automatically extracted from using the Smart Extract tool from a DWG. And you can see we can even just box select all of them. We can also use OCR or optical character recognition on a PDF. So not quite as seamless as a DWG, but certainly still works really fast. And once we have all of our dimensions selected, we can actually hide all of our extracted dimensions to make sure we have all of them, make sure we haven't missed one just by having it really nearby another one. Maybe we missed it. Once we have those extracted out, we can actually input our data directly in here. So we can do this all using a CMM, digital caliper, or even just by hand. And as we do it, you can see if you watch the drawing, we get instant visual feedback on the drawing of which dimension we're editing, which one we're measuring, and whether it passes or fails or it's close to failing. So we can export this data as well out to Excel along with pictures of the drawing. So we can take a picture of a failing dimension here, send it out to Excel, and get our full report of what this is going to look like. So and in Excel, we can see all that data we put in here. We can send this off to a customer if we need to and get all that information really easy. So the manufacturing and the quality departments today use some aspects of the design data. Usually it's just the 3D shape information, but in Industry 4.0, we really leverage that fully intelligent model that we've created, providing the full tolerance information to the CAM and the inspection softwares, which in turn expedites the process and it ensures that accuracy. So we're now finished. We've got our product ready to go, right? We're ready to contact ABCO and say, hey, we've got your design completed. So the biggest thing is, I think we can all agree that our engineering team in any company is generating great data. But today, a lot of companies are just kind of sitting on that pot of gold that's resident in engineering. We want you to realize what you have there, and we want you to leverage it, share it, and most importantly, get others to also contribute to it. So instead of just sharing your data, you can currently do that with screenshots and stuff like that. We want those other departments, that marketing department, to create those renders for us. We want to basically just create that digital twin. So create the thread that connects everything together and see how much your company flourishes with better products and better services. Data really is the key to Industry 4.0, and here at Javelin, our experts can help you identify how your company can benefit from its creation, collection, and the communication of all of your different data. So with that, I'd like to thank you for attending our Industry 4.0 webinar. It's a bit of a condensed version. If anyone attended our in-person ones, we spent a little bit more time on each subject, but certainly if you have any questions relating to any of the topics we discussed today, please reach out to your account managers or to anyone at Javelin, and we'll make sure we can get that information translated out to you. So thank you for attending.